Welcome back. Today we're going to take a look at something that is called a line of best fit. And a line of best fit is also known as a trend line. What we're going to be looking at are scatter plots like these. And we have a scatter plot. We're like, can we make a line that we can use to make predictions really? Can we think, okay, is there a pattern to this line? And number one here, our directions ask us to classify the scatter plots as having a positive, negative, or no correlation. Number one, yeah, that looks like a no correlation, right? I don't see any pattern whatsoever. So I just, that's no correlation. And I look here. Well, these seem to be headed downhill, right? So I would call this a negative. And it's not a very good line. So I'd actually call this, if I wanted to, I could say this, well, this is a weak negative. Here, well, we appear to be headed uphill. It's not a great line, so we'd call that a weak positive. Number four, well, this is much closer to making an actual line. If I drew a line through here, that'd be almost a line. So I'd actually call this a strong positive as we're headed uphill. Number five, those are pretty close to actually falling in line, so I'd call this a strong negative. And number six, well, number six makes a circle, right? So I'd call that no correlation. That is definitely not linear in any way. So up next, we are going to create this scatter plot. It says a math teacher asked her students how many hours of sleep they had the night before a test. The table shows the number of hours the students slept and their score on the exam. Plot the data on a scatter plot. So here I have my data. There's my hours of sleep and my test score. If you look here, numbers of hours of sleep, well, that's my X, and that makes sense. Time is usually X. And here's my test score, it's Y. So here's our coordinates, 883. So think about that as XY. 883 is another way of looking at that if you want to write it as an ordered pair. But we're going to graph each one of these, 883, 786, 774, 888. So we're going to graph each one of these on my graph, I guess, on a coordinate plane. And here you go. I have them graphed here for you. So each one of my coordinates is here. So like 883, here's 8. I'd go up and there's 83. Yep, it's there. 786, here's 7. I would go up, there's 86. So I could check each one of these, but these are my coordinates. And then it asks me for something a little bit more. It wants to know what's the trend. Is it positive, negative, or no trend? Is it linear or nonlinear? So it wants to know, does this data look like it's sort of like a line? And if you look here, could you kind of create a line out of that? I think so. So I'm going to call this linear. It's kind of in a line, not a great line, but sort of in a line. And it's headed uphill, so uphill would make it positive. So we call this a positive linear association. Today's lesson is really about the trend line. So a trend line or a line of best fit, either way, they're both the same. So if we want a line of best fit or a trend line, they mean the exact same thing. You start by creating a scatter plot, step one. We're done, got that, okay. Number two, determine if the data can be modeled by a line. We said, yeah, it can. This is a linear association, it's positive. And then it says, draw a line that appears to fit the data closely. There should be approximately as many points above the line as below the line. So I'm going to insert a line. I'm actually going to use my mouse here so I can get a line that's just a little bit more exact. So let me see here. If I create this line, I'm just going to put a line on here. Would this line be a good fit? It's linear, it's positive, it's going uphill. But if you notice, above I have 2 points, and below I have 1, 2, 3, 4, 5, 6. That doesn't seem to fit my data very well. I haven't cut it in half, so to speak. I don't have a good middle location. So what if I take and I move this over? What if I move it over to Switch my mouse. What if I grab this and I move it like this? Well, now I'm below my data. All my data is above. So I've got to kind of find some way of cutting this through. Looks like it's about even. So maybe right about here. Now it's important to note that when you work through these and you're putting a line in, they do not need to go through the points in the scatter plot. They do not need to connect. It's helpful sometimes if they do, but they do not have to. So I have my line of best fit here. And so using that information, looking here, which graph is the line most representative of the data? Explain. So look at A, okay, look at B, and look at C. This is kind of like Goldilocks. Look, A here, A is too high, all my points are below. B, my line goes right through the middle, which is good. And C, it's below my data. So I'm above my data, I'm below my data, and I'm right through the middle. So here, if I was looking for the best representation, I'd pick B. What if we turn that around and it looks something more like this? Instead of 3 separate graphs, it's only on one, and you need to determine your line. So my orange line here is 1, my black line is 2, and my pink line is 3. We need to know which one is most representative, which one cuts it in half, creates a line that we can use for prediction. Now look at number 1 here, and you know, that kind of looks like it cuts it in half. There's 1, 2, 3, 4, 5, 6 above. There's 1, 2, 3, 4, 5, 6. Well, there's a few more below. But if you notice, if I kept going with this line, this orange line is nowhere near my data as I move further away because my data is going to keep moving out this direction. If I look at the pink line, well, the pink line is actually all the way at the bottom of the data, which means most of it's above, so that's not going to work. But this black line just kind of cuts right through the middle and is following the trend. Therefore, it is the best line or the line of best fit for this scatter plot.